Welcome you all to the maybe last session before the midsem. This is going to be an important topic and most important from Python perspective as well on multiple inheritance. So MRO is an algorithm or the procedure by which when you have multiple classes, you have to suppose something is getting inherited from multiple classes, and if a method is not defined in the current class, it goes and searches all throughout till it reaches the topmost class. What is the order it searches for, and how is it resolved when you have different kinds of inheritance happening? So that's called MRO, method resolution order. There was one algorithm which was used prior to Python 2.3. There were some problems which could not resolve some issues when you are inheriting from different classes in some different order. So there was a new algorithm which is called C3 linearization. Linearization is nothing but listing down all the classes in which order you are going to be searching for a method which is not defined in the current class. Suppose the method is not defined in the current class, how is it going to look for it in the hierarchy? Okay, in which order? So that if you know the hierarchy of all the way the classes are inherited, if you have all the names of those classes, listing down the linear list of classes in which it is going to be searching for, okay, which is unique and which will not get into any trouble even if you are inheriting from different classes. So that is called linearization. C3 linearization is one algorithm which is being used from Python 3 onwards. So we are going to see this example today. Okay. I happen to see a good blog on this. I encourage you to read that blog. Okay. But mostly I hope I will be able to explain it and you will be able to follow in the class. So let us go start now. Okay. MRO is what is our focus is going to be today. I will explain the algorithm on PDF, and then we will see the implementation of that, and I'll show you the demo of that also. Okay. I hope I can do it in 1 hour. Let us see. Now, all these problems come because either some classes which are inheriting from the top parent, they override the classes. If they override the class, then some class is defined here. Override the methods. Some method is defined here, and then you define the same method here. Then it becomes easier for this class. If you are accessing, then it will call this method which is redefined here or overridden here. If it is not done, and you are looking for that method, then this, as I told you, the dictionary in the current dictionary is searched for, and if it is not found, it goes to the parent and then starts searching all through the hierarchy until it reaches the topmost class. Now, from Python 3 onwards, okay, if you are familiar with Java, you know that the grandparent of all the objects are object, right? That's the parent of all the classes. So similar to that in Python also, it is not capital O, it is small o. Object is a parent of all the classes. Okay, this is a class. The name of the class is object. Okay, so it will go till it goes to this object class, and then if it is not found anywhere, then it will give an error saying that that method is not found anywhere. So till then, it has to search all throughout your hierarchy of classes, and in which order it is going to be searching is the MRO algorithm or the linearization, how it is going to find the classes, in which order it is going to search that particular method which is not there. Imagining that it is not anywhere defined, then it has to reach up to O and then say that, okay, I am not able to find anymore because there is nothing beyond O. So it will say that that method is not found anywhere. Now, what is method override? Method overriding is an ability of any object-oriented programming language that allows a subclass or a child class to provide a specific implementation of a method that is already provided by one of its parent classes. Okay, not all classes, one of its parent classes. Okay, so if you are redefining something, it's not only method, even a class variable, and the parent class has a class variable, then you do it in our inherited class, you are defining it, then it becomes the local copy of the class variable. Then as far as this object is concerned, this class variable is now defined here. It will not go to that parent. Okay, that we saw yesterday. So now we are talking about methods which are getting overridden. Now when a method in a subclass, that means the child class, has the same name, same parameters or signature and same return type, or a subtype. Subtype means it could be a in a derived class object or something like that, as a method in its superclass. Okay, there is a method in the superclass and you are defining, overriding it with another definition with the same name and parameters, type of, no, there is no type actually, number of parameters, and then the method in the subclass is said to be overriding the method in the superclass. Okay, that's the definition of overriding. Now, as I told you, if you are not overriding, then if you are using the method, then it will be searching for that method in any of the parent classes. Now, prior to Python 2.3, what was followed? I will tell you. The method resolution order is the order in which a method or an attribute is searched for in the hierarchy of classes. In Python, the MRO is from bottom to the top and left to right. Okay. Now let me explain that. It means that first the method is searched in the class of the object, in the current class object. If it is not found in the current class of the object, if it is not found, it is searched in the immediate superclass. So it goes to the top. First it looks for that in the top, to the parent. In the case of multiple superclasses, suppose if you have multiple superclasses, it is not found in C, it goes and searches for B, whether this method is available in B. If it is not in B, then where does it go? It goes to the right. If you are, suppose if you have said that class C is inheriting from B comma A, then you are having multiple inheritance. Now you are using a method, some method here, which is not found in class C, then it goes to the parent, which happens to be the first parent. If it is not found here, then where should it search for? It will search in A. Okay, so go up and then left to right. Okay, that's what was defined in Python 2.3. Now C B comma A, then C it will be searched for current class. If it is not found, it will go and search in the parent class, the first parent of class C, which is B, and if it is not found, it will go to the second in the multiple inheritance to the right, A. Now suppose if you have A comma D, then it will search in D also. Okay, so go up and then search from left to right. Now this diamond problem is very popular in object oriented programming. Suppose if you have an inheritance tree like this, B and C are inheriting from the same parent, and now D is inheriting from both. Now there is an issue. Now let me say what is it. Suppose you are looking for a method which is not defined in D, then as I told you, it goes up to the parent, it searches in B. Now suppose you are looking for a method which is defined here also, then it would have, this B would have inherited this, and then this C also would have inherited this. Now you need to resolve that D is going to use the inherited version of what is available in B or what is available in C. Imagine it is not there in D. So it has to now choose between this. That's why our MRO itself came up, because of to resolve this diamond problem. this MRO or method resolution order was required to be defined. Okay, why is it so difficult or so important to define this order? Because the behavior has to be consistent across any implementation, and you may have the implementation of the interpreter of Python by many vendors, and the language definition has to be unambiguous that any implementation of that will behave the same. Okay, when you are writing a Python, you are going to be porting onto different platforms, and of course Python is so good in portability like Java. So we need to make sure that there is a common understanding or unambiguous way of resolving these kind of issues. That's why an algorithm is required, a well defined order is required. So in this case, as I mentioned, it will go up and look for that in B. If it is not there, it will go to the right. It will look for that in C. Then if it is not found, then it goes to A. So if suppose if it is not inherited from that method is not defined here, but it is defined only here, then it will come here and then it will go and then it will be finding it from C. So let me explain it. Assume that class D inherits from both B and C. Both B and C have inherited from A. Diamond problem refers to an ambiguity that arises when two classes B and C inherit from a superclass, a same superclass A, and the class D inherits from both the classes B and C. So there is a copy of A in both the places. So D should have an unambiguous way of taking which version of that I will take. Okay, it is okay to take any one of them, but there should be some consistent way of doing it. So if there is a method, that is method means some function m, which is an overridden method in one of B, okay, and C. Either is one of them. Suppose a method is only overridden in C but not in B, or it is only done in B but not in C, or in both. In all three cases, or none of them, then it should go to A and look for the same method in A. So in all the cases, you should have an unambiguous way of locating the method so that when you are using it in D, it will be able to find it in one of the classes in some order. So this is the order which is followed, which is goes up and then left to right, from left to right, and then again a superclass. Okay. So this also we'll see an example in our demo. Now this is a very straightforward algorithm, but it may not be suitable for all cases. So I'm going to explain you a new algorithm which is called C3 linearization algorithm, which was discussed with the inventor of Python, Guido, and then they all agreed to pull that into the Python 3 version. And then they also brought in a new one, okay, this class object. They brought in class object also. So in Python 3, every class is inherited from the base class object. Okay, it's a very contradicting statement. Class with the name object. Okay. Now we wrote yesterday class A. We also said class A and even empty parenthesis also is fine. But that actually means it is inheriting from class object. Okay, because we are using 3.8. So naturally it is actually object O is there somewhere. Okay, and it doesn't have to be mentioned because it is implicit in Python 3. So either you can define it like this or you can define like this because it's a built-in object with the language. Now Python 3 uses C3 linearization algorithm for MRO. It is different from what I told you. Go up, then search for that method from left to right, and then go up again. So that it is little different from what I told you. Okay, we will see that what is the difference here. Now we are going to call it as a linearization because MRO tries to bring all the classes, multiple inheritance that you have done from this class has done from many classes. We are going to order them and linearize it so that when you are calling a method and it is not found in the class, and then in which order it has to search for in the hierarchy is well defined. So we are linearizing the classes. Okay, all the classes above in up to the object. Okay, you should reach the object class also. Okay, that means if it is not found in object also, then that method is nowhere available. Okay, that's the last. It's like a god. You finally go to god to resolve the issue. Now let us look at the same diamond problem. Okay, and I'm going to call this as a small object, and this is class A, and this is class B, and this is class C. Now looking at the diagram, I am sure you will know how the multiple inheritance happens here. Class C is inheriting from A comma B colon, that's all. Okay, so we are going to inherit only this, and of course class A and B should have been defined, okay, here, and both of them are inherited from object, so they are not inheriting from anything. Okay, I am assuming that the superclass is our super god, okay, the object class. So this is the assumption. In this case, how is it going to be searching, and how are we going to find using this C3 linearization algorithm? Let us see that. Okay, now what is that algorithm says? Linearization, L is linearization of class C. Now when I say I want to linearize, I want to create a list of class names. I want. Okay, I will go in the order in searching for the method. So MRO is nothing but the interpreter is creating this list, so that when a method is not found in the current class, it is going to search through this list, MRO list. Okay, now we are going to see the algorithm which is going to build this MRO list. Okay, using this MRO algorithm, the list. Now when you want to make that list for the class C, what are you going to do first? First thing is, we are going to check whether it is available in class C or not. Okay, that's the first thing. Am I having that method at all? If it is there in this class, I don't even go up and look for it. I will use this method, which is defined in this class C. You will come here only when it is not there in class C. Now, that means you have to anyway make a whole list so that there is a list available. Now, it's a recursive definition. You find it in C. If you are making a list for class C, this is class C. This is a linearization of class C. You are making a list, which is a square bracket. First class is going to be C in that list, for sure. Then what you do, you want to merge it with list that you have made for class A, which is list linearization of class A and linearization of class B. Okay, that means what? You should have applied the same algorithm on this class, looking up its parent. Okay, similarly you are building this list for this class, looking up its parents. I am not saying parents, it can be any class, any level. So if you see that, it is first A's list is given and then list B is given. Okay, the linearization of B is given. That means it is going from left to right only. Okay, but it is building that list and then merging it. Okay, the a little different from what I told you earlier. And then it is going to include the class A and B also. Okay, um, I'll tell you the reason. We will look into the algorithm fully, then we will see. So these are all elements. One element, list of the linearization of A, which is going to have all its parents. Okay, this list is going to have all its parents. It is not going to have this class, because this is also in the same level. So this LA will have all the super classes or all the parents. Similarly, LB will have all the super classes. It is not going to have A in it. It is not going to have A in it. This is not going to have B in it. That's why we are adding a B also in the list for C, because we need to consider the C separately. we need to consider the classes A and B also separately. So we are doing it. But inside LA, anyway, you are going to start with A. Okay, that's a different issue. Okay, that we will see later. Now, you need to create a linearization list or a MRO or order for class C. So we are starting with C. Then we are going to recursively define, merge the list that you are going to make with the LA, comma LB, comma AB. Okay, A and B. Okay, A order A, comma B. Okay. Now, list LC represents the list in which order C is going to invoke the methods of superclasses. Okay, so this is the order in which the method in class C is going to be invoked. Okay, the one by one. If it is not found in first, it is going to search in the next. Now we have to find out how do we do the merging of this. Okay, merging is not straightforward. It is a little some steps are involved, so we are going to see that. Okay, but before that, I am not going to show you how to do this now, but let us recursively define how does LA is going to be found. Okay, LA is going to be found. Now look at LA. First A will be there. Merge it with what is the parent? LO. Okay, this is supposed to be O. I am calling it as a capital O, which is object. Okay, so I am saying A, when you are building the list, linearization list for A, suppose if it is not found here, you need to look up for the method, right? So you need to have a linearization list made for the class A also, and it needs to be there for class B also. Okay, now how is it going to be done? It is going to be A first. It is going to search in the A first, and if it is not found, then merge LO. You are going to look at the list of O, comma O. There is nothing called, there is no sibling there. There is only one class. We are not, superclass has not inherited from any other class because it's a O. So it stops with O. That's all. Okay. So LA is this much. Now I'm sure LB you can construct it now. LB will be what? Replace A by B, B, LO, O. It is going to be the same like what you see in LA. Okay. Now I'm not giving LB. Okay, LB is given because now, okay, wait a minute. How do you go to merge it? Okay. Now look at this list. LO is nothing but O. O comma O is single O. Okay, this is going to be just a O. I'm going to have AO. Okay. Similarly, list B will be BO. Okay, same procedure like LA, it will be BO. That means what? I am going to search in this A. This list says you search in A and then search in O. This list says you search in B, then search in O. That's what it means. Okay. Now you need to combine all of them for LC, which is you make a C merge of AO, BO, and AB. Now you need to have a understand how are you going to merge them all together. Okay, that I have not talked about, but I could merge it easily here because there is nothing beyond O in this list. Okay, LO is having only O, and then you have to look for no, nothing else is there beyond. Okay, then you can simplify this as a O. So it is very straightforward. But after constructing AO and BO, if you want to merge this AO, BO, and AB, you need to have some clarity on how are you going to merge them. Okay, that merge algorithm has to be there. So let us look at the merge algorithm now. Okay, I hope up to this point you are all clear. Okay, now let me first, same thing I am going to show. I am showing you the code of that. Class A is inherited from object small o here. I could have just written class A also, no problem. And the init self print class A, and then class B is taken from object. Okay, only thing is I should have written it as O object. Okay, which is not there. And then class C is from A comma B. and I'm printing class C and calling the super init here. Okay, so that's what the implementation for this. Now I told you that we need to now understand how I am going to merge this list. Okay, I need to make some order comma C comma A comma some B comma O or something else. I need to make this list. How am I going to do that with this AO, BO and AB list being there? They are all individual list. Okay, list inside list you can assume. Okay, now what is the algorithm? Take the head of the first list. Okay, when you want to merge, when you have multiple list you have, take the head of the first list, which happens to be A. Then call the remaining classes in the list as a tail. Now in our case, only O is tail. Okay, this is the head. You are going in the first, you are having multiple lists there. You are taking the head of the first list. So they are all individual lists. You have constructed from the previous list, you have brought it here. Now you take the head of the first list, then look for, then you call the tail as the remaining classes. In our case, there is only one class here. It could be more. So remaining classes as tail. Okay, the first step. Now second is, what is the second one? Step 2 is, if this head, in our case, this head is A, is not in the tail of any other list, now then you should know what is the tail of other list. Always the first element of any list is a head and anything else is a tail. Okay, this is a tail in this list, this is head and this is the tail. Okay, now what all the tail you have? Tails are, the first list have a tail O, the second list also have a O, and the third list is having B. These are all the tails. Okay, and the classes in them, they are the classes. Now let us look at the definition here. If the head, what is head? A is the head. You are picking up a head A, and then you are going to look into all the tails of the remaining lists. Okay, you are doing that in the step 2. So if this head, which is A, is not in the tail of any other list, is it there? Is it there? Okay, it is not there in both. Then add it to the linearization of C. Okay, now what do you do? If it is not in the tail, then you have to add it to the linearization list. Now already who is the first element which is selected? C is selected. Now I am looking at whether A can I add it to the list or not. Now I went through all the tails of the list and I did not find that A in any of them. But you found A in the head, but don't worry about it. Okay, I am only worried about whether I am finding that A in the tails of the other list. If it is there in the head, no problem. But I should not find it in the tails of the list. And I did not find, because there are only O and B are there, A is not there. So I can confidently now add A to my list. That means the MRO list has found, if I am not finding it in C, I am going to look for that in A now. Okay. Now, what I am going to do now? I have added it to the linearization of C now and remove all of its existence or instances from the list in the merge. That means what? All of its instances means it will be maybe in the head. Okay, if I am saying that it's not found in the tail, then only you are going to add. So when you are saying that remove all of its instances from the list in the merge, then you are going to remove, if it is there in A, in the head of any of the list, you are going to remove it. You are not going to consider it anymore because you are already added it. A, you are already searched for it. You are not going to search it again in A. There is no use in looking for the A anymore. Okay. So A, it should be unique. Whatever classes are there in the list should be unique. So A is there and I put it there and I remove that from the remaining heads. Okay. Otherwise, look at the head of the next list and take it if it is a good head. Good head means, what I mean by good head, I will tell you. Suppose I I searched for this A in the tail. Imagine instead of O, there was a A. That means it is there in the tail. Then it is not a good head. Okay. If I find it in some of the tails, I am not going to use this head at all. Okay. I'm not going to add it at all. If I find it in tails of any list. But if I don't find it, I'm going to add it and I'm going to remove if it is there in any other instances. If it must be in the head, so I will remove it. Okay, so I am talking about the other option. When it is found in a tail, what I am going to do with the A? I am not going to add it in the list. I am going to search by taking the next head. Okay, that's what. I'll show you an example for that. So hold on to that. Okay. So I hope this is clear. Now let me come again to step 3. Now A has been added. Now merge will be this because I have removed this A. So only B is there. BO is untouched and now A is anyway added, so I can remove it from this list. Now I am having OBOB. Now I need to merge this list. Okay. Again, you are going to start from taking the head here, which is O. Okay. Now, what am I going to do? When I take this O as a head, this is a head, this is a head, this happens to be the tail. Now, can I add O now? Because I am finding it in tail of one of my list in the down. So I should not add this O to the list. Okay. So as I mentioned in the algorithm 2, step 2, I should take the next head. Okay. Next head. And then I will apply the same algorithm. I am not going to find it in any of the tail because this tail doesn't have. This also doesn't have any tail at all. But it is there in B as a head. But no problem. Head is not an issue. So I am going to add B. Now that algorithm works here. I am going to add B. So CAB is done. Then I am going to drop the B occurrences in the list because I have already added it. I don't no point in looking at it again. Now what will I be left with? O only. I will pick this head and then I'll look for that in the tail. It will not be found because it's also head. I can add O. So CABO is found. Okay, this is the MRO or this is the order in which it is going to find the class, look for the method. So it will look for C, then it will look for the method in A. If it is not found, it is going to look for the method in B, then it is going to look for that in O. Then if it is not found anywhere, it is going to say error. Okay. So this is the order. You may see that it is the same as what we found. No, it is a little different. No, it is same as what I showed you earlier because that is what Python 3 does. And this is the algorithm. Okay. I hope this is clear. Now, let me show you a little more complex algorithm. Before that, let me show you the output. Now, suppose if I execute this, what will happen? Now, I am creating an object of C. Okay. Now, it is going to execute this init. Okay. Now, it is going to print class C. Okay, done. Then it is going to say super init. Now, because MRO says CABO, its super is this. Okay, super init is A, it's not B. Okay, for sure. So this super init has to have a resolution whether this is a super or this is super. Okay, that itself is a problem. Now I could say A is a super or B is also a super. Now because this MRO is there, already this algorithm has already run over this. I have a unambiguous way of picking up one of the parents as my next super parent class. So this is the same order. Okay, this is the same order as what you will be doing it for method searching also. So it is going to call a. Okay, not just because I have given this a b order, it's not going to follow that. And then you see that it is a b is given here, but it is going to do the b. Sorry, a is going to be done. Okay, is going to be calling the class a init. Super init is going to be a super init. So it is going to execute this init, and which is happens to be class a, and it stops there because it is not invoking any other init, as I mentioned earlier. Unless you specifically call the init, it's not going to call. So it stops. It's not going to call the init of the object or init of b or whatever. Okay, it stops there. So that's why you see the output as class a and c and a, which is getting printed. I hope this code is executed. If you execute it in the Python, you will be getting it. Now, one more complex example will make all your understanding clear. Please pay attention to this. Class A is here. It is inherited from B and C in the same order. Okay, I am going to say B comma C. Then class B has been inherited from B, E, D, E, F, and class C is inherited from D comma F. I'm sorry, B is only D, E, not F. Okay, D comma E only. B is inherited from D and E only. C is inherited from D and F only. And D is from O, E is from O, F is from O. So nothing beyond that. Okay. So there is a cross linking here happening. Okay. This kind of inheritance is also possible. Okay. Now, how are we going to resolve this? MRO, how are we going to build it using the algorithm that I explained you just now? If you follow this, which is there in the blog that I am shared it in the beginning, you can also read it, but I am sure you will be able to understand it when I am explaining now. Okay. Now, how am I going to create this inheritance or hierarchy, class hierarchy tree? Let me explain. Now, I am creating the class F from obj pass. Okay, pass is going to be in the next line. Please don't think that it is in the next, no, just for clarity I have given it, but it should be in the next line with a tab. E is inherited from object, just a class E, and class D is also inherited from object, nothing else. Now C is inherited from D and F, C from D and F, B is from D and E, A is from B and C. So I'm sure this is the tree which is getting constructed here, and I'm creating an object A1, and there is a method which I can invoke with respect to class MRO. If I call, it is going to give you the linearization of class A, what it has constructed. Okay, you will be finding all these classes. Okay, all these classes including A, you will find it in some order. Okay, but before we print it, we will construct it using the algorithm, so that you will find that it is the same as what we get from the MRO. Okay, now linearization of A is nothing but A first, merge of A is getting it from these two, LB, LC, then BC. BC is left to right. I hope this is clear. Now we need to construct LB. Okay, LB we need to construct considering these guys and this guy. Okay, similarly LC we need to consider considering this and this and this. Then we can merge it later on. So then we need to go up now. Okay, now let us look at it. We need to compute LB and LC to calculate LA. Now how do we do LB? We have to have B first, then merge. B is from this and this in the same order. This is nothing but DO, merge of DO and yeah, EO. Okay, EO, then D and E. I think this is clear. Now, how do I'll run the algorithm? Now, let me run the algorithm. I will take the head. I will look for whether the D is found in any of the tails of the remaining list. It is not there. Tails are having only O and E. D is not found. So I add D here. And then I remove the D from the head. Now I reconstruct the remaining list O, because D is taken care of. Then I can remove this from here also. O, EO comes as it is. Then E comes here. Now again I look for this. I will take it one step. I have not. Okay, we have to do it. We have to go in the same order. We need to consider any head that you find in the first list. So I need to, now this is the O. I am going to see whether I can add O into this or not. Unfortunately, I find it here as a tail. So this is a bad head. O is a bad head. So I am not going to add it now. See, bad head means don't think that I am going to throw it away, but I am not going to add it now. I will take the next head because there is no other head here. Only one head can be there in the list. So I can skip. I can go to the next list and pick up the head. Now I'm going to look E as a head. Okay. Now when I look for E as a head, E as a head, I don't find it in the tails of the remaining list, but I find it in the head. No problem. So I am going to add E. So then what will happen? O comma O will be there. Then I will find O. So B, D, E, O is the LB's list. Okay. Now B, D, E, O is the LB's list. This is what I have shown you. Okay. How LB is getting constructed, I already explained you. First BD is there anyway. E is going to be added. Then O is added. Okay. We have constructed LB now. Now it is similar, easy. You can construct it for C now. Okay, LC. Now I am going to construct the LC. First start with LC. C is going to be there. Then DO. C is DO, FO, and D comma F. DF. So these are the list. Now very straightforward. I am sure you will be able to now get it. Pick up the head. Look for that in the tails. Not there. Add it. Okay, CD done. Then remove this. Remove this. O, F, O, F. Then pick this O. Of course, you know from the past history that O is going to be a bad head. So, because it is there in the tail, so you are not going to consider it now. Defer it. Pick this head. It is not there in that list. Tails. So, F. Okay. So, F is going to be added. Then O is going to be added. So, CDF. Now, LC is done. LB is done. What you wanted this, you want to expand it into list of classes. You wanted to expand it into list of classes. You got it now because CDFO is there, BDEO is there, and BC is there. So all the classes are there. So I can merge algorithm. I can run it on this now. So I am going to go here by filling up these values. Remember it, BDEO, CDFO. Now BDEO, CDFO, and BC, of course. So this is going to be the list now. So I am going to do the merge now because all the classes are there. No more expansion is required. So I am going to take B now. Look for that in the tail. Look for that in the tail. Look for that in the tail. Luckily, we don't have B in any of them. So I can add B now. And then remove that. Remove this. Construct the remaining DEO, CDFO, C. Then take this head, look for that D in the tail, look for that in the tail. Oh, I found it. So D is a bad head. I should not add it now, defer it. So what you do, when I defer it, I am going to I need to consider the next head. Okay, so I'm not going to add D. DEO is kept here, CDFO is kept here, C is kept here. Okay, so I'm still not. I went ahead with the D, but I failed it there. So I am just going to look for a head by taking the C as a head, and I'm going to look for the next next class to be found. So I'm starting that C. I found. Okay, next head. Okay, now that is not there, so I am going to add it there. Okay, that I have done now. C is done. Now C is picked up because it is not in the tail and it is a head, so I will remove it. That entry is itself is gone. So you will have DEO coming down, DFO coming down. Now I am going to consider the D again. So I considered it here. It became a bad head, so I deferred it, but I kept it there. Okay, I will consider it later, but I don't want to add it before. Now I am going to consider D, EO, FO. Luckily, D is not found, so it can be added. Done. Then I remove this EO, FO. Then I am going to pick the E as a head, and then go forward. Will I find it here? No, I am not finding it here. So E will be added. Then remove that E, O and FO. O is open, happens to be a bad head to start with because it is there in the tail. So F will get added, then O will be added. So the final list will be A, B, C, D, E, F, O. This list is made. Now, when I print MRO, what I get is this is what is the output. Okay, A, B, C, D, E, F, O. A, B, C, D, E, F, O. Okay, A, B, C, D, E, F, O. So this is the algorithm. I hope this is clear. We are almost reaching the end of the class. I can just give you the code. I don't have a time to run it now. So in the sense, okay, I'll have to open it again. Sorry, I not deleted it. Luckily, MRO try is here. I don't need class. Okay, this is the program I have made. This is going to be given for a self-reading. Okay, I am sure you guys are smart enough to read this code and understand. Final one is what is given here. Okay, this pass is also accepting it. I thought it will not accept, but I don't know why. Maybe it is allowed, I think. Okay, tab is not needed, next line is not needed. I need to stand corrected. So what I get is this: A, B, C, D, E, F, O. O is object. O is not name, is not given. So this is what is the MRO. Okay, if you execute this, you will get it. Now remaining classes are all simple thing which I have written it for your self reading, which you can run it, understand it, read it. Okay, so with this